So for problem 37, we're taking a look at each one of these equations. So the first one being x equals 3y plus 6. And what we want to do is get the y by itself. Basically solve it for y so that it can be put into a graphing calculator. So when we're doing these, all we're going to do is essentially PEMDAS backwards. PEMDAS is parentheses, exponent, multiplication and division, add and subtract. So normally when we're simplifying, we go this direction. However, when we're solving for a variable, we're actually going to go in the other direction. So since I want to get the y by itself, I'm going to take care of anything that is being added or subtracted to the y. So I'm going to subtract a 6 from both sides. That gives me x minus 6 equals 3y. After I'm done with that, now I want to take care of anything that is multiplied or divided. So the 3 is being multiplied. And to undo that, I'm going to divide everything by 3. These reduce down to 1. So now I have y equals x minus 6 is all in your numerator, and 3 is your denominator. So that's problem A. For problem B, looking at that, the first step I'm going to do is add 10. So I have x plus 10 equals 5y, following the same pattern as A. And now, just like before, I'm going to take care of any multiplication or division. So divide everything by 5, leaving me with y equals, those reduce down to 1, x plus 10 in the numerator, 5 in the denominator. On problem C, x equals y squared. There is nothing that's added or subtracted. There is nothing that is multiplied or divided. So then we are dealing with the exponents. So to undo the square, I need to take the square root of both sides. Now with this, if I would go through and delete that underneath there and do the looking inside method and say what number here could I have squared and would give me x, which I had originally. And since when you square a number, it doesn't matter if it's positive or negative, it will come out positive after you square it. When I go through and take the square root of both sides, I will actually get two answers here. I'm going to get both the positive and the negative square root of x. And again, the reason why I have both the positive and negative goes back to the idea of the y value being squared. If that y value is positive, when I square it, it's going to come back positive. If that y value is negative, when I square it, it's going to also come back positive. We're going to want to use that information now for the next problem as well. Problem D. So we have x equals 2y squared minus 4. I am going to add or subtract here. I have a negative 4 that's being subtracted, so I'm going to need to work with that first. So I will add 4 to both sides, giving me x plus 4 equals 2y squared. I then have a number that's multiplied or divided, so I need to get rid of this 2. I need to divide both sides by 2. That reduces down to 1. So now I have a y squared equals x plus 4 over 2. So it's similar to the last problem. I now need to take the square root of both sides. And when I do that, I'm going to get two answers. Y is going to equal plus or minus the square root of x plus 4 over 2. And that is now my solution. Something to notice about this whole thing, x plus 4 over 2, has the radical symbol over it. So make sure that this part of your radical symbol goes all the way down to the denominator as well. If it would not, if it would look like this, then it looks like you're only taking the square root of the numerator, which would be incorrect. And the last problem. X equals, in parentheses, y minus 5 squared. So on this one, since the y minus 5 is inside of parentheses, I need to do the exponent first. So I'm going to take the square root of both sides. So I'm going to have y minus 5 equals plus or minus the square root of x. Now I need to get rid of that y minus 5, the minus 5 part, so I'm going to add 5 to both sides. And my solution is y equals plus or minus the square root of x, and after the square root symbol, outside of it, is a plus 5. This could also be written as y equals a positive 5 plus or minus the square root of x.